Hello, my name is Juan Perez Chica, and my content area as a prospective secondary school teacher is the subject of chemistry. For my internet tool, I've selected this website, End Memo, because it has a fairly large interactive space devoted to the subject of chemistry. Let me click on the chemistry label here. This brings us to the chemistry section of the website. As you can see, there's numerous categories and topics in the chemistry section that cover just about everything you'll come across in a high school chemistry course and more. From all the topics listed on this menu page, it appears like college students too can consult this section to get help for their chemistry university studies. This table I have my pointer on shows the variety of chemistry calculators this website offers in the subject of chemistry. Let me move my pointer to chemistry applications, which is right over here, and click on the first topic in this table called chemical elements periodic table. Here we see the periodic table with its numerous elements listed in the appropriate columns and rows. There's 18 columns on the periodic table. Columns go up and down. And there are 7 rows on the periodic table. They go across the periodic table. These 2 rows at the bottom of the table, called the lanthanide series and the actinide series, actually belong to the 6th and 7th rows of the periodic table, respectively. They're not in the 6th and 7th rows, at least visually here, because it would mess up the group or column organizations down on this end of the table. We want the elements in this column, for example, to be organized this way because it reflects the fact that all of these elements have the same number of valence electrons, which in the case of this column, the oxygen group, is 6 valence electrons. The elements in this adjacent column or group right over here, the halogen group, have 7 valence electrons. Obviously, if we inserted the actinide series and the lanthanide series directly into these rows up here, it would throw many of the elements off on this end, and interpreting characteristics of each of these elements like valence electron number and oxidation number would become problematic. As you can see, as I move the pointer around on the periodic table, I'm given both the atomic number of each element and the atomic mass of each element. For example, in the case of oxygen, I've got an atomic number of 8, and I've got an atomic mass of 15.9994. The atomic number tells us how many protons exist in one atom of the element. The atomic mass, or atomic weight, abbreviated here as MW, tells us how many protons and neutrons exist on average in the nucleus of one atom of the element. Now, on the table, the elements are abbreviated with chemical symbols. But if I move my pointer to an element, I'm provided with the element's full name. For example, I've got phosphorus here, and the chemical symbol is P. The reason why I like this interactive website is because of this feature right over here. Let me click on the moles to grams calculator. This is the moles to gram calculator you are now viewing. And this is an excellent tool that students can use to practice the very crucial topic of stoichiometry in the subject of chemistry. Stoichiometry is important because it can be used to tell us the molecular weight of a combination of atoms that are chemically bonded to each other, also known as a compound or molecule. The molecular weight is simply the sum of all the atomic weights in a compound. For example, if I type in hydrogen chloride here, hydrogen chloride has the chemical formula HCl, so let me type that in, and then I tap calculate here. I will be provided with the sum of all the atomic weights in hydrogen chloride. The answer is approximately 36.461 atomic mass units. The neat thing about the value for molecular weight of a compound is that it directly crosses over into something called molar mass. The molar mass tells me the weight that 1 mole of this substance has in grams. 1 mole of a substance is equal to 6.022 times 10 to the 23rd particles of that substance, also known as Avogadro's number. Anyway, 1 mole of hydrogen chloride has a mass of 36.461 grams. Notice that 1 molecule of hydrogen chloride has a molecular weight of 36.461 atomic mass units. 1 mole of hydrogen chloride, that is 6.022 times 10 to the 23rd molecules of the substance, has a mass of 36.461 grams. This is the reason why Avogadro's number is so important in chemistry, because of the immediate crossover in value between molecular weight of a compound and its molar mass. They both use the same value, but using different units. To confirm this using this calculator, all I have to do is type in the weight of hydrogen chloride in mass here. The mass of hydrogen chloride is 36.461, and here the units I'm using is grams. Now I want to calculate how many moles of hydrogen chloride there are, and I should get a value of 1. Yep, so I get 1 mole there. In other words, 1 mole of hydrogen chloride provides me with a mass of 36.461 grams. The same value as its molecular weight with atomic mass units. Anyway, what makes the moles to gram calculator so useful is the fact that I can type in any arbitrary mass for a compound, and I will retrieve the number of moles for that mass of compound I'm working with. Students can use this feature to check their answers when they're working on a stoichiometry assignment out of the classroom. But of course, this website has many other useful calculators and features, which is why I selected it for this presentation on Internet Tools.